Okay, now let's stay with two investments, but let's allow diversification, meaning they're not mutually exclusive. Now we're talking about a portfolio where you can buy a part of A and part of B so that you have a combination of the two, or at least you potentially can do that. So we're going to choose a combination of our wealth to invest in A or B. Because it's portfolio, we have to bring in some arithmetic, where this CR is the expected return to this portfolio, where this PI represents the portion of the portfolio's value invested in investment I. So P1 is the proportion of the portfolio value invested in investment I, or investment 1. A and B, we moved to investment 1, investment 2. So just keep that clear in the nomenclature. And so if you had $100 to invest, and you put $50 of that portfolio value in investment I, then 50 over 100 is 0.5 or 50%. So the P, the proportion would be 50%. And this R represents the return to that investment 1, whether it's 10% or 50%, whatever that is. And the P2 represents the proportion of your portfolio value in investment 2. And this, of course, the R2 is the rate of return to that investment 2. And so it's just a weighted average to see what your investment would be. Very straightforward. Now the risk and the variance is, of course, a little more complicated in this formula. However, this formula for variance, if you've had a statistics class of some form or another, you've seen this hundreds of times. You still may not like it. You still may want to avoid it. You may even want to ignore it, but here it is again, and it represents the variance to help us to calculate or to measure risk. And this V represents the variance, the P represents the portfolio, and the I represents the variance of the investment I, okay, or the dispersion around that mean. The S represents the standard deviation, which is the square root of the variance. And this gamma subscript 1 and 2 represents the correlation between the investments 1 and 2. Now correlation, again, is something that you may be in denial, but I know that you've studied correlation a number of times. The correlations between two stochastic variables can be between a -1 and a +1. As you know, as a +1, they move perfectly together, right? If they're -1, they move exactly opposite of each other. And if they're somewhere in between, they don't move exactly, but if it's a positive correlation, they have a tendency to kind of move together. If it's a negative, they move somewhat counter to each other, but not perfectly. That's what makes up this formula for the variance. Now let's look at two investments, investment 1 and investment 2. And let's say that investment 1 is Belgian bonds. Got a very high return, but they also have a very high variance. Let's say that investment 2 is maybe U.S. Treasury bonds instead of the Belgian bonds. Probably don't know what those are. Let's say that investment 1 is Microsoft. Microsoft is a little more risky than the Treasury bonds, isn't it? Has a higher return. We'll just say Microsoft, you're going to have a higher return, but it's a higher risk. The Treasury is going to have a lower return, but a lower risk. What that means then, if we put more of our wealth in Microsoft, then it's going to what? It's going to increase our expected return because it has a higher return. Looking at the portfolio risk, again comparing Microsoft and the U.S. Treasury bonds, if the correlation is less than 1, okay, it's not perfectly correlated, then investing some of our money in Microsoft can actually reduce risk. Whoa, think about that for a minute. A little bit counterintuitive, isn't it? We're saying that in this more risky asset, Microsoft, if you put a little bit of your wealth into Microsoft, you can actually reduce your risk. And not only that, because it's got a higher expected return, your portfolio value is going to go up. Kind of interesting, isn't it? Okay, thus a portfolio of these two investments, Microsoft and the Treasury, having investment in both of them actually dominates only investing the one with the lowest variance. It is better for an individual to have money not only in the Treasury bonds, but also in Microsoft, and it's got a higher return with a lower risk. Is that interesting? The portfolio mix, however, between Microsoft and the Treasury depends on the risk-return preference of the investor. We can clearly state that a combination of the two dominates just having your money in the Treasury, but how much Microsoft to put in your portfolio depends on the risk-return preference of the individual. Now, if the correlation happens to be a -1 or perfectly negatively correlated, then it's possible to combine the two investments, the Microsoft and the Treasury, in a manner that will eliminate all risk. That's a little strange, isn't it? If they move exactly counter to each other, you can combine them in a way that the risk actually is zero. Now, to find two investments that are perfectly correlated or negatively correlated, now that's a stretch, okay? But if they were, you could combine them to reduce all risk. If it's perfectly correlated, if they move exactly together, where the correlation is 1, then diversification doesn't provide any risk reduction. It's just only risk averaging, because that correlation component just drops out. Now, graphically, as I promised, in this particular case, and pay attention up here at the beginning so that you understand these graphs. Risk, as measured by variance, again, is on the vertical axis. The expected value is on the horizontal axis. And we're looking at the combination of Microsoft and the Treasury. Now, right here at this leftmost point, represent all of your portfolio invested in the Treasury, where you can see that you have a lower expected return, but you have a low variance or low risk. If you move to the other side, to the rightmost point on this graph, over here, this represents your total portfolio in Microsoft. Any of these points in between the two represents a combination of Microsoft and the Treasury. In other words, by adding Microsoft to your Treasury portfolio and removing some of your Treasury, it's actually going to increase your profit, but it also increases your variance because, in this case, it is perfectly correlated. So there's no risk reduction, you're just risk averaging. Not terribly interesting on this one because you seldom have this particular case where you have investments that are perfectly correlated. So let's add a case where they're correlated. They move together but not perfectly. They're following each other but not perfectly. Okay, if you look at this, notice again that this leftmost point is your risk return if you had everything in Treasuries. Now notice that these points stay the same on all the graphs. The correlation doesn't have any impact. You have no diversification. But notice something interesting here. Notice that it's going down. As you bring in Microsoft into the portfolio, your returns are going up, but your risk is going down. Everything from the point where this is the minimum, somewhere around a little over 60, everything to the left of that is dominated by everything to the right. That's where we said if your investment's not perfectly correlated, then adding Microsoft to your portfolio always is going to dominate having everything into your Treasury. Why would you ever accept anything less than 60 if you could reduce your risk? Everything to the right of that point, right where that's a minimum, all along here then, from point X to point Y, your choice of Microsoft between those points depends on the risk-return preference of the individual. Some individuals will choose a high return with a high risk. Some individuals will take a low return with a low risk, depending on the risk aversion that each individual has. But all individuals are going to invest a portfolio that at least gives them this return X, because they can do that at a lower risk. Let's look at a case where the correlation is zero. They don't move together. Okay, there's no correlation between them. Notice that by adding Microsoft to your portfolio, you can go from $50 to $70 return and lower your risk. And again, between those 2 points, X and Y, those are your efficient set, and you would invest somewhere between X and Y, but where your portfolio mix, again, depends on the individual risk-return preferences. And now let's go to a case where there's a negative correlation. And notice that you have even a greater potential of reducing your risk by adding Microsoft. Even though it has a higher risk, you can see that you can actually lower dramatically your risk by adding Microsoft, the risky investment, to your portfolio if they're negatively correlated. In the case where they're perfectly negatively correlated, notice that by adding Microsoft to it, you can actually reduce your risk to zero. Again, you're not going to find many investments like that, but conceptually you could do that, and then your set would be from point X to point Y. This next step, just to make your notes complete, I'm not going to ask you to reduplicate this particular formula on an exam, but when you go to the next level, this is more in line with the things that you're going to see. So this is kind of a stepping stone into your next level of your risk analysis or finance. What I'm doing now is I'm relaxing the assumption of just 2 investments. Now we're saying that you have N possible investments, not just 2. And the expected return is just the proportion of each investment multiplied by the rate of return or profit associated with that, and we sum them up, and that's going to give us our expected return. And then the variance, we have to add another summation sign to it, but we still have the proportions, the standard deviation, and the correlation between each of those. And if you look at that, those look scary, but in fact, they're just tedious. They're just simple multiplications and additions. Okay, the relationship for a portfolio with more than 2 investments is similar to a portfolio of 2 investments. Risk reduction is possible through diversification, and we can calculate an efficient set, as we've defined before, by calculating the minimum variance for a given range of expected profit. And we can do that through math programming, where you have an objective function subject to constraints, and we can use that to come up with the efficient set. And basically what we do is we enumerate all of the possible investments that you have, and then we, given any level of expected profit, we minimize the risk, and that then draws those points, what we call the efficient set. Okay, that efficient set dominates all of those others in the feasible set. And of course we have the infeasible set that we've talked about before, some investment that lies way out here that has a very high return with no risk. They don't exist. So those type of things are infeasible. And then to add the economics content to all of this, back to some of the things that you've learned in your Econ 323 or some of your other basic economics course, we have this efficient set, and then we have a family of indifference curves that define for us the trade-off that we have between risk and return. It shows that we're indifference between this level of risk and return, and we're indifference between this level of risk and return. It sets up that pattern of indifference curves. Okay, here's a quick summary of your economics. And then we know that by choosing the level of indifference curves until it's tangent to that curve, that becomes our optimum. Okay, depending on this individual's level of risk-return preferences, you can actually theoretically derive in this multiple investment scenario your optimum portfolio. And we have then our optimal investments that is dependent on this individual's risk-return preference. Because you could have, of course, another individual whose indifference curves look like that, and their risk-return preference would be different. Again, these latter two and the multiple sets, I'm not going to test you over that, but if you're going to go on, okay, this is your next level. This is where you get into more of the advanced. When you're looking at your decision in the stock market of which set of stocks that you have, you are looking at multiple stocks and you're trying to pick those stocks that basically maximizes your expected utility. And this is the framework that defines how that can be structured, theoretically as well as in a way that can actually maximize your returns. So this is just out there for you as a stepping stone